So we're going to partition a directed line segment. Okay, so when I say partition, this is going to be in a 2 to 3 ratio, or sorry, this is going to be in a 3 to 2 ratio, meaning if I could split this up nicely, 1, 2, 3, 4, 5. My first 3 pieces will be red. 1, 2, 3. My first 3 pieces of that line, if I split up into 5 pieces, would be red. The next 2 pieces would be green. So I gave myself a ratio of 3 to 2. 3 red to 2 green. Okay. Just a visual to see like what a partitioning is going to be. Okay. When I look further into this one, I need the coordinate that splits that up. I mean, I could eyeball this and say, okay, it's around here somewhere. Right? That kind of looks like it's going to split up in a 3 to 2 ratio. But I need to be sure, right? So what is that coordinate? Right? Sometimes it works out nicely, sometimes it doesn't, right? But I want that coordinate to work out nicely. So I'm going to erase this. So somewhere around there. I need, if you think about the coordinate A, how does the coordinate A get to coordinate B? How does the coordinate A get to the coordinate B? How does the x value get from 3 to 6? How does the x value get from 3 to 6? By adding or what? Or subtracting what? Yeah. So to get from 3 to 6, I'm going to add 3 units. That would bring me all the way from A to B. What if I asked you about the y values? Again, I want to get from A to B. How do I get my 2 to 8? Yeah, I'm going to add 6. That would get me from A to B. What I want to create is a point P on this line somewhere, wherever this point P is, and again, I'm just estimating that right now. It could be anywhere. I want to get this point P somewhere so this line is in a ratio of 3 to 2. So when I think about the 3 to 2 ratio, to get from 3 to 6, I don't want to travel all the way to 6. I only want to travel part of that line. Right? So if my ratio is 3 to 2, what fraction do I need to travel to get from 3 to 6? And you're going to get this from the ratio. Yep. Okay, close. Your ratio is 3 to 2, which means that if you, as a part-to-part ratio, right, part-to-part, what you guys did in 7th grade is 3 to 2. What if I ask you, what's the ratio of part to whole? What's the part-to-whole ratio? Yeah, one of them is 3 to 5, which can also be written as a fraction of 3/5. So when I take this coordinate of x, when I take my x, I'm going to pick on my x coordinate here. So I need to get both of them. So when I take the x coordinate, for example, I'm going to take the x coordinate of my a, my starting x coordinate, or I'm going to take this x coordinate here to start. I'm going to move it somewhere. How much am I moving it? So I'm going to add something to it. I don't want to add all 3 units of it because that would get me all the way to point B. I only want to add some of the 3. How much of the 3 do I want to add? And I want to add, I want to add 3/5 of that 1, 2, 3 units to figure out where that new point P is. And the same thing is going to happen with the y coordinate. I'm going to start at that 2. And again, if I add the 6 units, that's going to bring me all the way to 8. I don't want to get all the way to 8. I only want to get 3/5 of the way to 8. So I'm starting with your x and y coordinates, my starting points. I'm going to think about my part-to-whole ratio and my part-to-part, part-to-whole ratio, and that's going to come into play. And then I'm going to think about, well, how much do I need to get all the way to my x? How much do I need to get all the way to my y? And then once you do this little calculation here, so 3 plus 3/5, this is just going to be, let me erase this a little bit. this is going to be 3 plus 9/5, or 3 plus 1 4/5, or 1.8. So 4.8 is going to be the x-coordinate of P. And if I add this one, this is going to be 2 plus, this is 18/5, or 2 plus, if I convert this into a decimal, 3 3/5, or 3.6. This will give me 5.6. So, and if I graph that, 4.8, here's 4, here's 5. 4.8 is somewhere around here. And if I follow that all the way up, should get me right around 5.6. And that's partitioning